Hey, how's it going, guys? This is Mr. iPoc here for actually lesson 2.6 notes. I decided to do a video lesson just because we've missed 2 days of class this week due to map testing. So I wanted to make this video so we could keep a good pace going. And we are on a good pace for everything. So jumping into this is going to be due, this homework's going to be due on Monday. So if you get done, obviously if you got done with your map test early, you're working on this, watching this video, you can once you feel good with the notes, you can stop and go to the homework. The homework's actually going to be on the back side. And there's 8 problems for homework of just working through the quadratic equation, or excuse me, quadratic equations via the quadratic formula. So we've learned 2 ways to solve quadratic equations. So we've learned 2 ways to solve quadratic equation. We know one way, and that came from a video lesson, and that was factoring. The other way we learned this week is completing the square. And then today you will learn how to solve quadratic equations via or by the quadratic formula. Now the advantage of the quadratic formula is oftentimes you'll find a quadratic equations, and I'm not going to debate this with you. I think factoring is the most efficient way to solve a quadratic equation. It's not going to take near as much time, but not all quadratic equations are factorable. So you can't factor all quadratic equations, so you have to kind of look elsewhere. Same way with completing the square. Not everything's going to be a perfect square trinomial, so you're not always going to be using completing the square. But I can guarantee you that any quadratic equation can be solved with the quadratic formula. So any equation, it doesn't matter what it looks like, what the numbers are, any equation can be solved. And when I say any equation, I mean any quadratic equation, meaning it has a square. Any equation can be solved using the quadratic formula. So just kind of wanted to throw that out there. Again, factoring, you're going to look at some of these and be like, man, I can factor that pretty quick. But I'm just trying to set you up for the process to see that you can, if you want to pause the video and factor this on another piece of paper and then compare your answer to the quadratic formula. But we need all 3 because you may get to a test one day and you're going to say, oh, 1 times negative 24, I can't find 2 multiples that multiply to that and add to the middle term. So then you're going to have to say, well, what I do, I'm going to use the quadratic formula. So that's why it's valuable to know the quadratic formula. The quadratic formula there's songs about it. They sing songs. If you want to sing songs, sing songs. I don't care. I just need you to know it. So opposite of b, so negative b plus or minus the square root. This is the formula. The square root of b squared minus 4ac all over 2a. That right here is our formula for quadratic equations. To solve any quadratic equation, that's our formula. We know we have other methods. Okay? We need it in the form of ax squared plus bx plus c equals 0 in order to put it into this form. If you can get your equation like this, which you can just by moving things around if you need to, combining like terms, but we need it in this form in order to plug and chug. Once you get it here, it's just plug and chug, and it's very simple from there. So many students prefer to just use the quadratic formula every single time because many people have trouble with factoring. We tried to close that understanding gap to try to help all of you understand factoring a little bit better. But if you don't understand factoring that great, you feel more comfortable with this, you can use this on a test. Okay, so whatever it takes. So solve each equations with the quadratic formula. Let's start with number 1. So I'm going to go in here to number 1. K squared minus 2k minus 24. So notice from the beginning, it's in this ax squared plus bx plus c equals 0 form. That's a good thing. already from the start. And we know that K right here, there's a 1 there. So we know A is going to be 1. Feel free to go to the side and just write them out. A equals 1 because that's right here. B equals -2. And C equals -24. So from there, we're now just going to plug it into the system. I expect on your homework, I will check this to make sure that every single problem has the formula. You got to get it. You have to memorize this. You have to get it down. Again, go sing a song, make a rap song about it. Do whatever you need to do. Go talk to your dude 6ix9ine and have him rap a song about it. Oh, wait. Oh, yeah, sorry. So we got -b plus or minus the square root of b squared minus 4ac all over 2a. So now we're just going to substitute these values in. So the opposite, so it's like -b. So the opposite of b, well, if b is -2, the opposite of -2 is 2. Or you can think about it like this, -2, which is +2. So we got 2 plus or minus the square root of b squared, which is -2 squared minus 4 times 1 times -24. And we're going to put that all over 2 times a, and a is 1, so 2 times 1. Once we take it from there, we're going to simplify all this. We got 2 plus or minus the square root. Well, -2 squared is 4. -2 times -2 is 4. Minus 4 times 1 is 4. And 4 times, -4 times -24 would be a +96. So it's actually a +96. And then that's going to be all over this 2 times 1, which is 2. Once we get there, we're going to go ahead and add those two numbers, and that'll lead us to 2 plus or minus the square root of 100 all over 2. Now I'm going to bring it up here and say 2 plus or minus, well, what is the square root of 100? The square root of 100 is 10, so 2 plus or minus 10 all over 2. And we can kind of break this down a couple different ways. We want to, the first thing, we could simplify this, or if you feel comfortable, just kind of, because you can simplify it and say 2 goes into all of that, or you can just kind of break it down into 2 things and say this. 2, because it's a plus minus here, 2 plus 10 divided by 2, and 2 minus 10 divided by 2. So 2 plus 10 is 12. 12 divided by 2 is 6. 2 minus 10 is -8. -8 divided by 2 is -4. So our answer then, just like we would get if we factored it, would be 6, -4. So you're going to have 2 answers for these quadratic formulas. That's not an XY coordinate. That's 6 and -4, and your order doesn't necessarily matter. Okay, going to number 2. So looking at number 2 real quick. Again, let's start. We got A, B, and C. So it's okay to come to this side and say A is 2, B is 4, and C is -6. And we're just going to plug it all into the formula. That formula is the opposite of B plus or minus the square root of B squared minus 4AC all over 2 times A. So plug our values in. We're going to have the opposite of 4, which is -4. Again, if I just put 4 in there, that negative sign would still be there. So -4 plus or minus the square root of B squared. B is -4 squared minus 4 times A. A is 2 times C. C is -6. And that's all over 2 times a, which is 2. Once we get it there, let's simplify. Negative 4 plus or minus the square root of 16. Negative 4 times 2 is negative 8. Negative 8 times negative 6 is a positive 48. So again, negative 4 times 2 is negative 8. Negative 8 times negative 6 is positive 48. And that's all over 2 times 2, which is 4. When I add this, I get negative 4 plus or minus the square root of 16 plus 48 will lead us to 64 all over 4. From there, we're going to bring it up here and say negative 4 plus or minus the square root of 64. It is 8. So plus or minus 8 all over 4. Then from there we can kind of split it up because it has two signs here. So it's negative 4 plus 8 over 4 and negative 4 minus 8 over 4. So negative 4 plus 8 is positive 4. 4 over 4 is 1. Negative 4 minus 8 is negative 12. Negative 12 over 4 is negative 3. So we have 1 comma negative 3. And that would be our answer. Okay. And again, as I said in that last one, if you wanted to change this to negative 1 plus or minus 2 all over 1, that would be fine as well in working that out. And that would just be by simplifying that, or you can just go straight here. Totally up to you what you do there. Going to number 3. So we still have it in that format. We still have it in the format of ax squared plus bx plus c equals 0. So let's continue with that. So again, we're just getting that practice, trying to nail it down. So we got the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we say the opposite, or let's go ahead and label them. A is 2. B is negative 2, and C is negative 6. So the opposite of B is 2. 2 plus or minus the square root of B squared. B would be negative 2, so negative 2 squared minus 4 times 2 times negative 6. And that's all over 2 times A. 2 times A is, or 2 times 2. We'll go ahead and put 2 times 2. So then from there, we clean that up. We say 2 plus or minus the square root. Negative 2 squared is 4. And then negative 4 times 2 is negative 8. Negative 8 times negative 6 is a positive 48. And we put that all over 4 because 2 times 2 is 4. And then we say 2 plus or minus the square root of 52 all over 4. Now let's move this up here, and we're going to say 2 plus or minus the square root of 52 all over 4. Now, the unique thing, notice in our other problems, we had a perfect square root of 100. We had a perfect square root of 64. But now we have a square root of 52, which is not a perfect square root. So what we need to ask ourselves is, can we simplify this any? Going back to what we saw, about simplifying radicals, I spoke briefly about it. So if you're looking at the square root of 52, what you want to ask yourself are two numbers that can multiply to give us 52. Are any of those numbers, are either one of any of those numbers pairs or factors, multiples of that? Is it, multiples? Are they? Are any of them perfect square roots? So let's just start. Well, we know we got 1 in 52. And then we got 2, half of 52 is 26. So 2 in 26. 3 won't go into 52. But 4 will. 4 and 13 will. And also, well, anything else? 5 won't, 6 won't, 7 won't, 8 won't, 9 won't, 10, 11, 12. Yeah, and then we're at 13. So nothing else will go in here besides this. So we actually see that this square root 4, so you could kind of check off, well, 1's a square root, but that would take us to where we're at. So that won't work. These two won't work. 2's not a perfect square root. 26 is not, but 4 is. So we're going to change the square root of 52 to this, the square root of 4 times the square root of 13. That is the square root of 52. These two are equivalent. But now we can simplify this because the square root of 4 is a perfect square root. We can simplify it down to 2 and say 2 times the square root of 13. And that's the square root of 52 simplified. So now we can rewrite it here as 2 plus or minus 2 square root of 13 all over 4. Now the neat thing here is that we actually, we can simplify this. Kind of like what I talked about here, how we can simplify this right here. We could simplify it to this by dividing everything by 4. Well, same thing here. We can simplify all of this besides the square root of 13 because 2 goes into all 3 of these. So 2 goes into itself once, so 1 plus or minus 2 will go into that 2 once. Bring down your plus or minus. 2 will go into that 1 time. So we really don't have to, we can say 1 if we want, times the square root of 13. And then all over 2 will go into 4 2 times. So this is what our final answer will be here, but we can kind of split it up to where it looks like this. So we got 1 plus the square root of 13. I don't have to include that 1 over 2, comma, 1 minus the square root of 13 over 2. And this would be my final answer. I can't, it's in simplest form, and I can't do anything else besides this right here. It's in simplest form. I could get a decimal form of this, but I would just keep it in fraction and radical form. All right, number 4. Looking at number 4, if I'm looking at looking at this one, I still have it in the ax plus b x plus c form. I can kind of label these. I'm running a little tight on space, but that's okay. I can say a is 2, b is -5, and c is 1. If you don't need to label that, don't label it. It's completely fine. You just do whatever you need to do. Be selfish academically. So we're going to say the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And again, I'm going to be looking for that formula on the homework. I'll write myself a note to remember, look for that formula. So here we go. The opposite of b, well, b is -5, so right now it's always going to, this number right here will always be opposite b, so it's going to be 5 plus or minus the square root of b squared, which is -5 squared, minus 4 times 2 times 1. And that's all over 2 times a, which is 2. Again, we're solving a quadratic equation. We could do this potentially by factoring. But even if you look at this right here, look at this. 2 times 1 is 2, and no two factors of, or the only factors of 2 is 2 and 1, and they will not add to give you -5, so this is unfactorable here. So you would absolutely have to make this or solve this with the quadratic formula. Then going from there, or you could add, or you could move the 1 over and then try completing the square if it creates a perfect square trinomial. All right, so but we're with quadratic formula, just kind of feeding you some information there. So going on from here, we got 5 plus or minus the square root of 25 minus 4 times 2 is 8. 8 times 1 is just simply 8, so 25 minus 8 all over 4. And then from there, we're going to say 5 plus or minus 25 minus 8 is actually going to be the square root of 17 all over 4. When we go from there, we want to take it up here and say, all right, 5 plus or minus the square root of 17 over 4. So we ask ourselves, pull that square root of 17 to the side and say, can I simplify this? Well, what are the factors of 17? Well, just 1 and 17. If it can't be simplified, then it's in simplest form, so this would be our answer. So our answer is just this split up. 5 plus the square root of 17 over 4. 5 and 4 can't be simplified. There's nothing that'll go into them. And then 5 minus the square root of 17 over 4. And that would be our answer there. Hope this is making sense. And again, this is an unfactorable. You can't factor this quadratic equation, so you'd either have to use completing the square root of the quadratic formula. Most students, and the students I've had in the past, they would probably go straight to quadratic formula. Looking at number 5, got 2 more problems, and then I'm going to let you go. So looking at 5, now this shows us something different. It doesn't have 0 on the side, so we need to move that constant over here to get 0 on that side. So add that 2 to that 1, that cancels. 5b squared plus 2b plus 3 equals 0. So then we say, all right, what's A, B, and C? A, B, and C, well, A is 5. It's right here. B is 2. C is 3. We use our formula. The opposite of B plus or minus the square root of B squared minus 4AC all over 2 times A. So then from there we fill everything in. So we got the opposite of A, or excuse me, the opposite of B is, the B is 2, so it's going to be negative 2 plus or minus the square root of 2 squared minus 4 times A, which is 5, times C, which is 3. Once we're there, we can then say 2 times A, so 2 times 5 is 10. And then we got negative 2 plus or minus the square root of 4 minus 4 times 5 is 20. 20 times 3 is 60. So 4 minus 60 all over 2 times 5, which is 10. And I should be seeing the steps here, guys. I don't want you to just go like from here straight to the answer. Show your work. Show what you're doing. So then we got negative 2 plus or minus the square root of negative 56 all over 10. So let's bring that up here. Negative 2 plus or minus the square root of negative 56 all over 10. Now, we actually have a square root, and we have a square root that is negative. So that's what we've discussed that this week about those imaginary numbers, because there's nothing you can multiply by itself and get negative 56. But our question is, can 56 be simplified? Can negative 56 be simplified? We'll deal with the negative here in a minute, but let's bring 56 over here to the side. So like the square root of negative 56. Ignore the sign right now. And here's what we want to do. We want to go through here and say, okay, are any of the multiples of 56 a perfect square root? So let's start. We got 1 times 56 is 56. And that will take us to where we are, so we really don't need that right now. We got 2 and 23. Well, we know those two won't work because they're not perfect square roots. 3 will not go into 56, but 4 will. 4 and 14 are perfect square roots, or not perfect square roots, but are multiples of 56. And also 7 times 8. Now, if you're looking at this, there is only one pair that contains a square root, and that's right here. This contains a square root. This pair, 14 is not it, but 4 is it. So we can rewrite the square root of negative 56 as this. The square root of 4 times the square root. Now, the only thing is one of these have to have a negative in order for this to be, in order for it to equal. So we'll just put the negative with the 14 because we want to simplify 4. And as you know, the square root of 4 is 2. So 2 square root of negative 14. Now we deal with this negative right here. Now, so we have, or actually let's bring this back up here and let's rewrite it as this right here. So I hope you kind of understood that progression. If not, hey, talk to me. So we got negative 2 plus or minus 2 square root of negative 14 all over 10. Now notice here, so we went from the square root of negative 56. We found what it could be simplified to, and that's 4 and 14. So we changed it from negative 50, the square root of negative 56 to 4 to the square root of 4 times the square root of negative 14. And then we simplified the square root of 4 to 2, and then we got that, so we moved it up here. Now, if you can notice right now, we have 3 numbers right here that all can be simplified. So again, the key is to get it in simplest form. So 2 goes into all these. 2 will go into negative 2. Sorry, something looked a little weird there. 2 will go into negative 2, or excuse me, 2 will go into negative 2 negative 1 time. And then we have plus or minus 1 right here, 1 times the square root of negative 14 again, and then 2 will go into 10 5 times. So we have negative 1 plus or minus 1 times the square root of negative 14 over 5. Now, we know we don't need that 1 there, and we can deal with that here in just a second. But here's what I want to deal with. We can deal with this negative 14. If you remember from yesterday or from this week, when we have a negative square root, it doesn't have to be a perfect square root, but this can be rewritten like this. The square root of 14, you can split it up based on its multiples. The square root of 14 times the square root of negative 1. And as we learned this week, the square root of negative 1 is equal to what? It's equal to I. So we have the square root of 14 times I. Now the format of this is going to look a little bit different because we don't want to put the I after that because some people can get confused. So the way we want to write it is this. Negative 1 plus or minus the, and we're going to put the I in front of it. So negative 1 plus or minus I square root of 14. Notice we lost the negative now because we pulled the negative out by doing this right here. By writing the I, and then that's all over 5. So we have negative 1 plus I square root of 14 over 5, comma, negative 1 minus I. So I just kind of split it up there. My video acted a little weird, so sorry about that. I jumped a little ahead. So I went ahead and moved that 2 over to get that constant to get in our form. And then I did A, B, and C. And then I got negative opposite of B plus or minus the square root of B squared minus 4AC all over 2A. And then I plug everything in. So that's negative 3 plus or minus the square root. And pause the video anytime if I'm kind of going too fast. And then we got 3 squared minus 4 times 2 all over. Or actually, I am so sorry. There was a mistake there. 2 plus 2 is not 2, it's 4. So C is actually 4. So that's actually a 4 there. Over 2 times 4. I'm glad I caught that. That could have been nasty. So we got negative 3 plus or minus the square root of 9 minus 4 cubed is 64. So 4 times 4 times 4. All over 8. And then if we solve that, we got negative 3 plus or minus the square root of 9 minus 64 is actually negative 55 all over 8. And if you take that negative 55 to the side and ask, okay, what are the multiples of negative 55? Well, we got 1 and 55, and we got 5 and 11. Nothing else really goes into 55. So what we'll say with that is that none of that's going to work because none of them are perfect square roots. So that's in simplest form. But what we do want to do is say negative 55, break it down into the square root of 55 times the square root of negative 1, and then change that negative 1 to an I. So it becomes the square root of 55I or I times the square root of 55. So then we can rewrite that as negative 3 plus or minus I square root of 55 all over 8. And then we can just simply break that down. So negative 3, so my answer is negative 3 plus I square root of 55 over 8, comma, negative 3 minus I square root of 55 all over 8. Hope that helps. Hey, if you need any help on this, your homework is just directly on the back. There's only 8 problems, so I want you working them all using the quadratic formula, so work that. If you need help, I'll take any questions over the homework on Monday morning. Thanks so much.